Hello dear students, very good morning all of you. Let's start today's topic. Before starting that, I am going to say you something. Dear, in previous class we have done some numericals of this chapter. Now I am going to start a new topic, that is liquid pressure. Okay? So, have a kind message to you. Please, every accomplishment start with decision to try. So dear students, wherever you are, let's try for your goal. Don't sit and think only the time will come and then I will start. Just proceed towards your goal and achieve the goal. Dear, it should be a meaningful message for you. Please try. Try to study. Try to think what you want to do in your life. Try to learn what will be the path for what you are thinking in your life. Please come to the point now. Okay, dear, here we have to start pressures in liquid. Okay dear, so first of all, as we know that liquid and gas have not a fixed shape, because whatever the container in which we pour the liquid, the shape of the liquid becomes the container in which it is kept. Okay dear, so in which container you will put, the shape of the liquid becomes of that container. So it has no fixed shape. That's why its surface of contact will change from container to container. Dear, as if you are putting the liquid in a cylindrical shape, the liquid will take the shape of cylinder. If you are putting in a conical shape, it will take a conical shape. Okay, so the contact surface, the surface of contact between the liquid and container, as container changing, the surface of contact is also changing. That's why it will be different for different shape. Dear, one thing we also know that liquid molecules always moves in a random motion, zigzag motion, that we have also known as Brownian motion, zigzag motion. Okay dear? So it is continuously moving. Okay, gas and liquid, both particles of this matter, this format of matter, are in continuous motion, and that's why it collides to the container. Okay, and that's called pressure. Dear, when molecules move randomly and after taking a high speed, it go and just collide to the surface of container and exert some force and on that surface, and that was a pressure. Okay, that's how liquid exert pressure. Okay, liquid not exert only pressure in downward direction. Okay, it exert in all directions. Okay, that's why pressure exerted by the liquid on the walls of the container inside way is called as lateral pressure. Okay, so simple, what do you mean by liquid pressure? It means that liquids molecules are in random motion, and due to that motion they attack or they collide to the surface of container, and that causes what? Pressure on the container's walls. Okay, that's how liquid exert pressure on the walls of a container. Dear, Liquid pressure is measured by a device called manometer. Manometer is a device which is used to measure the pressure exerted by liquid. Okay. It is U-shaped tube containing a liquid. Simple, it is a U-shaped tube. It is shown in your book that there is a wood shape. In that there is a U-shaped tube in which there is a measuring a scale, and this is a plastic funnel on which is just put in the liquid, and that liquid pressure exert the pressure on this liquid, and that liquid will rise on that will show the scale reading. Okay dear, so that's how we come to understand how liquid exert pressure. Simply, as we know that pressure is equal to force upon area. It means that force exerted by liquid particles on the container, okay, and the area of container taken, that's cause a pressure on the container. Do you understand now? Because it is in zigzag motion, random motion, Brownian motion, and continuously colliding to the surface of the container and exert pressure on the container surface, and that pressure per unit area cause liquid pressure. Okay. Now, liquid pressure increases with depth. Dear, now I am moving to the topic that is characteristics of liquid pressure, nature of liquid pressure, behavior of liquid pressure. Here, liquid pressure increases with the depth. It is a simple process you can just do in your home. It is a simple activity. Take a manometer and just take a bucket of water. Okay, dip the funnel of the manometer to some height and read some pressure on the U-shaped tube. After dipping higher than previous dip, you will find there will be a more pressure. It means, take an example. There is a two fish. There is a two fish in this bowl. One is at h1 distance. h1 distance means h1 is less than h2. Okay, and the another fish which is at higher depth means h2 near, which have a high pressure on it, means the fish 2 which is inside a more depth, okay, from the level of the liquid will have a higher pressure. Okay, on that fish liquid will exert more pressure because of depth. In higher class we will taught you what a formula for liquid pressure, that is rho gh. Dear student, pressure exerted by a liquid is rho gh. Rho means density of liquid. Density of liquid. Okay dear. G means acceleration due to gravity. G, acceleration due to gravity. Due to gravity. H means depth from the top of the surface of liquid. H, depth inside the liquid from the surface of the liquid, from the top surface of the liquid. Okay, so H. So this formula P for pressure is equal to rho gh. It means that if a liquid have high density, means it will exert more pressure. If a liquid has a substance which is higher depth inside the liquid, will exert higher pressure. Okay, means when you move inside the liquid in the ocean, you will be a large amount of pressure on your body. by the liquids of ocean. Okay. Liquid pressure is the same in all direction given at a given depth. Means that remains same. Understand this? There, liquid pressure at the same height means take there is some height, some level. At here you will find same. At here you will find same. At here you will find same. Here you will find same. On the surface of liquid at same height means if you are not changing height, then there will be no change in pressure in all directions. Whatever be the direction. Okay. In this direction, in this direction, in the upward direction, in lower direction. At same depth, there will be a same pressure, remains same in all directions, as it is mentioned in the diagram here. Here, he is taking the funnel in left side, right side, okay, and one is horizontally downward on the same level, and the reading is same at for every action. Okay. Liquid pressure depends upon the density of liquid. Here, as I mentioned you, a formula pressure of liquid, that is rho GH. In this, if a liquid have a higher density, means it will exert the higher pressure. Come to the point. Liquid pressure depends on the density of the liquid. For example, take an example. Take two balloons. That is rubber membrane. Yeah, if you will take a balloon. Two balloons. Put same amount of water in one balloon. Let's say 1 liter of water you are putting in one balloon, and 1 liter of kerosene, oil, any oil, petrol, diesel, whatever you want to take in another balloon. You will find the water has the balloon containing water have a larger shape, while the balloon containing kerosene oil or petrol, diesel, etc. have a smaller size. It is because of its density. Okay, dear? It is because with higher density exert higher pressure. That's why its size becomes bigger. Okay. Liquid pressure does not depend on the shape of the container in which it is poured, and it sets its own level. Okay. Let me take an example. Liquid pressure does not depend on the shape of the container. Okay. It only depends on the height of the container. Okay. So here is three shapes I am taking. One is cylindrical shape. One is inverted cone shape. And one is upright and vertical. Let's say that. Okay. This type of shape type. If you will pour some liquid in this container, okay, it will go inside. First of all, it will hold position of this and start rising. Okay. At same level, it will get same level in each shape. Okay. The rise of the liquid in the container will be of same height for each case. Okay. And next, whatever will the pressure generated by the liquid in this container, in this container and in this container will be same. Okay, so when you are pouring a liquid in any of this container, it will take at the same level means same height, and will exert the same pressure. Liquid exert lateral pressure. Dear, lateral pressure means take a container like this. Okay, make a hole here. Okay, you will find and take a what rubber membrane here. You will find liquid starts flowing from here to here and increasing its speed. Why this? It is because liquid not exert pressure only downward, it also exert pressure inside way, left, right, okay, up, down, okay, in every direction it's exert pressure. The side direction, the pressure exerted in side way is called as lateral pressure on the container. Okay, so let me clear you some effects of pressure in our day-to-day life. When a person who is used to go inside the liquid in the ocean, that is at a high depth, okay, deep in the sea, divers wear a special suit. Means a person who is to go inside the sea at a higher depth, that is sea diver, he used to wear a special type of suit for protecting himself from the high pressures of liquid, okay, on him. Okay, sometimes you might have seen that aquatic animals fish inside the ocean at a high depth, okay, bears a high pressure of liquids on himself. That's why its blood flow with a high speed, okay, as some pressures exerted by liquid on them. When fish is taken out from the sea, the fish burst, the body of fish burst, फट जाता है. It is due to high pressure of blood inside the body of fish. Dear, it happens due to. Okay. So I hope you are able to understand these topics. If you have any problem, dear, please ask during Google class. Okay. Thank you.